Hi, welcome back to this series where we are looking at Snowflake Cortex, which is a series of products and services that Snowflake provide that helps its customers leverage ML functions and large language models out of the box using data that exists in your Snowflake environment today. Now, root cause analysis is a crucial aspect of data-driven decision-making within your organization. And Snowflake's Contribution Explorer is a ML function provided as part of the suite of services within Snowflake Cortex that helps you streamline and enhance the process of identifying different drivers which are resulting in certain outcomes for your organization. So Contribution Explorer is a tool developed to simplify and improve the process of root cause analysis for changes in these observed metrics. And so by analyzing these values of a specific metric over time, Contribution Explorer identifies the data segments driving these shifts within your organization. And this helps businesses understand the underlying factors which are influencing these key performance indicators. Now, in our series so far regarding Snowflake Cortex, we've covered the classification, anomaly detection, and forecasting ML functions, which leaves this final one, Contribution Explorer. Now, this works in a slightly different way to the others, which require you to build and train a model before passing new data into it so it can categorize it, forecast what's going to happen in the future. The Contribution Explorer, however, acts more like a table function which analyzes the data that you pass into it. Also, this function isn't actually called Contribution Explorer. The function's actually called Top Insights within Snowflake. So why is Contribution Explorer useful? Well, it's really helpful for organizations looking to quickly identify and address issues affecting certain outcomes in their business. So for instance, if a company notices a sharp decline in sales, the Contribution Explorer can determine whether the drop-off is due to specific locations, salespeople, customers, industry verticals, or a range of other factors that you provide it with. This allows for immediate, targeted corrective actions, minimizing the impact of these negative trends. Now, some of the key features of Contribution Explorer are it can really excel at segmenting data based on various dimensions that you pass into it. And these dimensions can be categories such as location, market segment, or continuous like temperature or attendance. And that flexibility ensures that the Contribution Explorer can handle diverse data sets and provide insights tailored to different business needs. And Contribution Explorer takes that data, separates those into different segments that have the most significant impact, and that makes it easier to identify the root cause and take those corrective actions promptly. Now, to leverage Contribution Explorer in your queries and pipelines, you can use that Top Insights function that we mentioned earlier. And that function is designed to pick out those important dimensions within a data set, build the segments from those functions, and detect which ones have influenced the metric in question. And so if we go back to our sales performance drop-off example, where it's creating a revenue shortfall, you would prepare your data, first of all, to include those different dimensions, such as location and salesperson. You would then pass that to your Top Insights function, which would then take those segments from your data and apply the Contribution Explorer to it. The Contribution Explorer then will return a result set, and that will highlight which locations or salespeople or customer segments are driving or influencing the revenue shortfall. And that might not be obvious for you or any other person in the team just looking at the data. Finally, once you know what's driving that revenue shortfall, you can take quick corrective action to address that business problem. So let's take a quick look at the demo of how this works using a sample data set. Here we are in our Snowflake environment, and I've used synthetic data to create our data set, created a table called mortgage applications. Notice I've used these functions to create things like first name, last name, date of birth, a city, and then I've also got different categories here of employed, self-employed, and unemployed for the employment status, as well as annual income, credit score, property value. And then I've also got a column, which I'm going to be using is our label. The thing that we want to look at and predict is around fraudulent mortgage applications. So it's going to be true if it's a fraudulent application, or false if it's a normal, non-fraudulent application. So we're going to execute that command to create our data set with 100,000 records in there. Let's just take a quick look at that data. the top 10 records. We've got first and last name, we've got a date of birth, we've got a city, employment status, and the other columns. Then notice our fraudulent applications. We're going to get quite a lot of them compared to some real world data just because of the nature and the way that I've generated this table, but it's purely for demonstration purposes. Now, over the top of this table, I'm going to create a view called VW_mortgage applications. I'm just going to pull out all the columns, but the reason why I'm doing this is I'm going to show you how you could potentially prepare and bucket some of these attributes together to get a better, more accurate model at the end of this. And I'm taking the annual income and I'm simply grouping it into certain categories using this case statement and creating an additional column on here called annual income groupings. So I'm just going to run that view. And that's going to create that. And that's what I'm going to use as my input then into the top insights table function next. So if I scroll down here, I've got a create or replace table as, and I'm using a CTE within this then, where I'm using my top insights table function, which is down here. Before we get down here, let's just take a look at the inputs I'm creating. I've left credit score out for now because I think if I want to use credit score at the moment in my mortgage applications table, my credit score could be anything from 0 to 1000. And I'd probably want to add that into my view with some grouping to kind of add those into certain buckets to make it more usable. So that's one way that you could extend this approach. For now, I've just left it out and I wanted to leave it there to show you what the approach might look like for that. Instead, I've taken the employment status, the annual income group, and the property value group is dimensions that I'm going to pass in to my table function. And then notice I've got this statement here because it needs to be provided as a Boolean data type for the label. I'm just saying if the fraud column is equal to 1, then it's true, otherwise false. And that's getting passed in to my table function, top insights down here, where I'm passing in all of my categorical dimensions in one go and any continuous dimensions as well. So I'm going to execute that and that's going to populate my table. Notice I've also got this over partition by 0 clause, and that ensures that the table input is processed together. So I've got my mortgage applications results table set up. Now in this case, I've ranked these results by the surprise column and I've limited it to the top 50. Now here's my results set. I've ordered it by the surprise column, which represents the amount by which the test metric in the segment exceeds its expected value based upon that metric change. So you can see here, for the employment status unemployed, I was expecting 11,132 applications which were fraudulent, and I actually got 33,000. So the difference between the two is the surprise ranking. So what we're saying here is if the employment status is unemployed, that's a key driver behind the fraudulent mortgage applications we're seeing based upon this data set. And so essentially I want to start looking into these employment status applications in more detail, potentially also introducing additional dimensions like the credit score before, so I can take some corrective action. This is just a sample data set, so notice that we're getting some strange results in terms of the annual income and employment status here. We've actually got a negative surprise because I'm getting the actuals far lower than the expected values, but you get the idea. You can pass in these dimensions. The Contribution Explorer using the top insights table function will take these individual dimensions, split them into segments, and give you an idea of where you should focus your efforts to take some corrective action. So that's it for our short demo. So I hope you found this video useful. If you and your organizations need any help around leveraging Snowflake Cortex, then please reach out to myself or one of the team at Intelligent.